Okay, so now I want to talk about finding the domain of a rational function. So remember that the domain of a function is all the possible input values, that anything you can possibly put into a function, that's the domain. So the domain is all possible inputs. Okay, so when we have a function, typically you can put in anything you want, right? You can just put in all real numbers. So we would usually, if we had f of x equals x plus 2, you can put in anything you want in there, right? There's nothing that's going to stop you from putting any input that you want. So in this case, the domain is all real numbers, which we usually write with this r with a double bar. So when we're looking at a rational function, though, remember that a rational function is a function that has a fraction in it. So like f of x equals x over 3 minus x is a good example of a rational function. So the thing about a rational function that we have to keep in mind is that we can't divide by 0. Okay, so we can't divide by 0. So that's what we need to keep in mind with this rational function. So in this case, the problem's going to happen if the bottom of this fraction is equal to 0, right? We can't have something over 0. So when is the bottom of this fraction going to equal 0? When x is equal to 3. So if x is equal to 3, then we're going to get 3 over 0, right? And that cannot happen. So this cannot happen. So x cannot equal 3. So another way of writing that would be that x can go, so the domain is all x values, so that x goes from negative infinity all the way up to 3, but not including 3. So we use parentheses to indicate that we're not going to include 3. And then we do the union of that with everything from 3 to infinity. So this says all real numbers can also be written as negative infinity to positive infinity, right? It's everything, all the numbers from negative infinity to positive infinity. If we want to exclude 3, this is the way we write it. So all that we mean is we're saying take all the negative numbers all the way from negative infinity all the way up to 3, but then at that point don't include 3. So you can have 2.99999, but you can't have 3. So then union that means take this together with all of the values from 3, but not including 3. So you can have 3.0001 all the way up through infinity. And this is how we would write that. So let's try one more example. So let's do another rational function. Let's do 1 over x squared minus 4. Okay, so I can't have anything where the bottom of this fraction equals 0, right? So you might be able to just see what numbers are going to be the problems here, but if you can't figure out what numbers are the problems here, one way that you can do it is to take x squared minus 4 and actually set it equal to 0, and then you can solve this. So for example, I would take, I can factor this, so it's x plus 2 times x minus 2. That equals 0. So then we would get x equals negative 2 or x equals 2 by setting each of these equal to 0. So if we now know that x has to equal -2 or x has to equal +2, those are actually the problems. And in this case, x cannot equal -2 and x cannot equal +2. And that's because if we plug in either plus or minus 2, when we square it, it's going to be +4, and when we subtract 4, it's going to be 0. So we can't do that. And what we want to do instead is write down our whole domain. So we want to have, our domain is going to be, it's going to be all real numbers, but x can't be -2 and x can't be +2. So if we wanted to write that in interval notation, we would say going from -infinity all the way up through -2, but don't include -2. Then we want to include all the numbers between -2 and +2, but don't include -2 and +2. And then we also want to include all the numbers from 2 to infinity. So it's kind of a cumbersome way to write it sometimes, but this means the same thing as this. It means all real numbers where x can't be -2 and x can't be +2. So we go from -infinity to -2, don't include -2. In addition to that, we're taking -2 to 2, don't include 2, and then 2 to infinity. And that's how we find the domain of a rational function.